Okay, so I'm just going to start with the degrees. What do we have here? 0 or 360 degrees. This one is 90. This one is 180. And of course, mine doesn't fit on the screen. That's going to make it annoying. 270. Let's see if I can fix it a little bit. All right, halfway through, between 0 and 90, halfway through is what number?
45.
45. And then all of these are the special ones. So the special ones are 30, 45, and 60. And then we're using every angle that is this size is a multiple of 30. That's why this one's 60. This one's 90. So this one is what? 120 degrees. This one over here is 150. I'm just counting the 30s. I'll go back and put that one in a moment. Here's 180. What's the next 30? 210. So we're doing multiples of 3. 210 and then, whoop, this one here. 240 and then 270 and then another multiple of 3. 300, 330, 360. And then we could keep going around and around and around again, but we don't need to. So I just need to go back and put in the multiples of 45. So like this one here is 45. This one is twice 45. This one's going to be 3 times 45, which is what? Oops. 135. Good. And then we've got 180 plus another 45. 225. And then plus another 45 is 270, plus another 45 is 315. So we got all of our angles. Next thing we're going to do is get all of our radians. And we did an activity like this before break. So let's see how much we remember. This one is either 0, or if we go all the way around in radians,
2 pi.
2 pi. If I go halfway around, pi. So if I go a quarter way,
Pi over 2.
this is pi over 2, because that's half of the pi. So to get the radians, it's easiest to look at the top half and think about dividing that pi into sections. Better late than never. Okay, so if I take this and I divide it into 4 equal sections, if I divide the top into 4 equal sections, each of them is a 4. Pi, the whole top, divided by 4. Pi divided by 4. That's going to be this answer right here, pi over 4. Where do those lines go? And then this one is 2 pi over 4. And then this one is 3 pi over 4. And then pi is 4 pi over 4. And then if we keep going, this next one is going to be 5 pi over 4. This one is 6 pi over 4. And then 7 pi over 4. And then we get back to 360 degrees is 8 pi over 4, which is 2 pi. So we're counting by pi over 4s all the way around. Okay, well, what about if we do the 30 degree? How many 30s fit into the top half? 6. 6 pieces of that pie. 6 30s sit up there. So the first one is pi divided by 6. So you've got to remember that 30 degrees is pi over 6. So the second one is going to be 2 pi over 6, but that does reduce to pi over 3. The third one is 3 pi over 6, which reduces. The fourth one is what is it? 4 pi over 6, but that reduces to pi over 30. And then the fifth one is 5 pi over 6. Notice how I'm saying the fifth one is 5 pi over 6. The sixth one is 6 pi over 6, which reduces. Then we've got 7 pi over 6, which does not reduce. Then we have 8 pi over 6, which does reduce. Oh, wait, did I really never fill that one in?
Yeah.
Oops. So that's 8 pi over 6. This is 9 pi over 6, which reduces to 3 pi over 2. And then we've got 10 pi over 6, which reduces to 5 pi over 3. And then we've got 11 pi over 6. And then we've got 12 pi over 6, but that one we already have written down. So you need to be able to come up with these values, and you need to know where they're located. So once we did the 45s and the 30s, we got every single one, but we could do the 60s if we wanted to. We could look at the 60s. How many 60s fit into the top half? The one thing that people get like tricked up about, like making mistakes on with the 60s is there's only 3. So 1, and then 2, and then 3. It doesn't stop at 90. The 60s don't. The other two do. The 60s, like this includes the 90 degrees at the top. It doesn't stop there. So 1 60 is pi over 3. 2 60s is 2 pi over 3. 3 60s is 3 pi over 3. And then we've got 4 pi over 3. 5 pi over 3, and then 6 pi over 3. So the 60s are pi over 3s. The 30s are pi over 6s. And 45s are pi over 4. Questions so far? Yeah, we will. All right. I heard this cost. It says how long it was, even though it's gone. Okay. Ordered pairs. 4 of them you already know, right? No?
I know.
Okay, we've got what ordered pair here?
1 0.
1 0. We've got
0 1. Negative 1 0. 0 negative 1.
excellent. Now, we're going to take this a little bit at a time. We're first going to talk about this ordered pair. All right?
Yeah.
To get that ordered pair, we have to go over a certain amount, and then we have to go up a certain amount. Now, I'm not asking for a number answer. I'm asking in general, like, what is this that I go over? That is the
X over Y.
X. And then we go up the Y value. We go over the X, and we go up the Y. And then this is a unit circle. This is a unit circle. So what do I know about my radius? It's 1. On our lesson 2 days ago, last class, we talked about how the sign in a unit circle, the sign of theta in the unit circle is Y. The sign is 1. Okay? That's for the unit circle. For the regular circle, it would be Y over R. But unit circle is Y. What is the theta for this particular triangle? 30. So what is the sine of 30?
1/2.
So what is Y? That's my Y. Now let's do that again, but let's find X. So what do I know from my lesson last class? That cosine is X. And this is the cosine at 30 degrees. So what is, from our chart that we're memorizing? Square root of 3 over 2.
Oh my goodness.
Boom, we have an ordered pair.
That is awful. That is the worst thing I've ever seen.
It's not the worst thing ever. And it's going to be like half of your year next year.
I'm dropping out.
Well, you can't because you need it to graduate. Well, you dropping out of school?
Yeah.
Okay, well, it'll be 4. All right, sine of theta. Next one. What is our next theta? I'll make this in a different color so we can see it. Our next theta, I don't have any more colors.
Yellow.
Hold on, I need to be creative here.
And green.
Okay. Oh, some of you may not be able to tell. Sorry. Sure, he's used to it. All right. Sine at what theta?
45.
So is that 45? So sine of 45 degrees is radical 2 over 2. What's cosine at 45 degrees? Radical 2 over 2. And then I have another triangle. Where is it? It is orange. Orange?
Blue brown.
It's not brown.
Doing college students.
That one looks too similar. Oh well. So we've got another one. We've got what theta for this one? 60 degrees. So this time we're doing sine of 60 degrees. And what is the sine of 60 degrees?
Radical 3 over 2.
Radical 3 over 2. So that's going to be our y value. And what's the cosine of 60 degrees? Half. Once you know those ordered pairs, you can find all of them.
They're negative some of them.
Yeah, so let's look at quadrant 4. Let's just look at quadrant 4. I'm going to go back to, actually we'll just do the one we just did, that 60 degree one. In quadrant 4, this one here is like a reflection of that 60 degrees. So this one's also a 60 degree right here. It's just down in the 4th quadrant. So if I were going to go x, then y, it's still the same x. It's still the exact same x. It's just now instead of going up for y, we go down. So when we write our ordered pair, it's going to be the same x, 1/2, and then the y is now negative square root of 3 over 2.
That makes life better.
Right, because you really only have one quadrant that you have to learn.
I'm not going to drop out anymore.
Okay.
It also helps.
Glad I knew that. What did you say?
It also helps if they follow the same thing that we did for the sheet. So 1/2,
Oh yeah.
2,
Mhm.
3.
Oh, exactly, and that's why we did that sheet so much, and are doing that sheet so much. I should say we're not done with it. All right, so the next one. I did not draw it very well. So when I do that 45, this one's going to be the same exact x. It's the same exact x. It's square root of 2 over 2. But the y value, instead of going up, we're going down. So negative square root of 2 over 2. If I'm going too slow for you and you get this, fill out more of them and then you can check your answers when I have the rest of the answers. So then I'm going to do this 30 degree. And I know the sine of 30 is 1/2, but when it goes down, it's negative 1/2. And when it goes, the x is still the same, square root of 3 over 2. So in 4th quadrant, y's are negative. They're the same values, just y's are negative. Question. Okay, remember the theta is the one that is at the origin and connects to the x-axis when you do these. The theta is at the origin and connects to the x-axis. So over here, the 30 degree one is this one. And to get there, I'm going to go left and then up. Our left amount is the cosine. Our up is the sine. This is a 30 degree angle facing that way. So we go left, how much? So it's gonna be negative square root of 3 over 2, and then up 1/2. And you can see if I go up a half here, or if I go up a half over here, they're the exact same length. All right, so then we're just mirroring these. We're doing the exact same ones, except the x's are negative over here. So I'll just fill the rest of those in. This one is negative square root of 2 over 2, square root of 2 over 2. This one's negative 1/2, square root of 3 over 2. And then down here, we are mirroring these points, except what do we know about negatives over here? Both negative. So this one is going to be negative, oops, marker, negative square root of 3 over 2, negative 1/2. This one will be negative square root of 2 over 2, negative square root of 2 over 2, and then this will be negative 1/2, negative square root of 3 over 2. All right. Woo. We're doing okay. Now, do we need a small brain break?
Yes.
Okay.
No.
No? All right. Reference angles. Reference angles. We've already kind of talked about reference angles, but we haven't used them for anything yet. We're going to use them today. A reference angle, there's 3 things that are very important about the reference angle. First thing is that they're always positive. It's a positive number. It's never a negative number. It's always a positive number. The second thing is that they are always acute. What does acute mean?
Less than 90 degrees.
Between 0 and 90. Between 0 and 90. Okay. If it's radians, it would be between 0 and what would the radian be? Pi over 2. Okay. So that's the second thing, is that they're acute. And then the third thing is they always go to the x-axis. They're always at the origin and x-axis. So you guys are actually doing reference angles yesterday with the ordered pair. You were using that theta that was at the x-axis. You just didn't call them reference angles yet. Now there is a formula to find the reference angles depending on which quadrant it's located in. I think this is more work than just figuring it out by hand. So if you are somebody that absolutely needs a formula, if it's in the second quadrant, this is what you do. If it's in the third quadrant, this is what you do. If it's in the fourth quadrant, this is what you do. But this is not going to be given to you. So if you can just figure it out, it's going to be better. So I'm just going to figure them all out. I'm not going to use this formula, but you can use it if you want to. So there's 2 questions here. We're going to do question B first, just because it's degrees. And to do the reference angle, the first thing that you want to do is just draw the negative 130 degree angle. So we're going to draw our chart, and then we're going to go negative 130 degrees. So I'm going to go clockwise. This is negative 90. This is negative 180. So negative 130 is around here-ish, right? The reference angle connects to the x-axis in the origin. It's a positive number. It's between 0 and 90. So what I'm thinking here is, how much do I have left to get to 180? 50?
Yay, math.
So they call the reference angle theta prime because it's not the actual theta, it's a reference from the theta. So theta prime is 50 degrees. So I'm just thinking how much left to get to the x-axis. That's what I'm always thinking, is how far away it is from the x-axis. What do you No, but they do say to draw it in your homework, so we'll draw it. And hopefully eventually you will be able to figure it out. Mhm. I would love if you could just do that in your head. Not everybody can. Okay, so the next one is 5 pi over 3. And I put a little arrow and a little note that I added in to help us. I'm going to explain that note in a second. Somebody wants in. We're doing notes from Missed a lot of fun too.
Oh my God, yeah.
Okay.
Which is sarcasm. I got it.
All right. So what do we do when it is when it's radians? So your choices for radians, I'm going to do it, but leave it in radians the whole time. You can take the radian, convert it to degrees, draw it, find the reference angle, and then take that reference angle and convert it back to radians. Or you can just stay in radians the whole time and save yourself, half the time. So that's what I'm going to do. What I'm going to look at the pi divided by 3 part first. So pi divided by 3 says where's pi on my chart? Halfway. So if I take halfway and I divide it into 3 equal pieces, you might even think, oh, those are 60-degree angles. Okay. I'm going to divide it into 3 equal pieces. Each one of those is a pi over 3. How many do I need? 5 of them. So I have 1, 2, 3. I got to keep going. 4, 5. So here's my 5 pi over 3 line. So what is left to get to the x-axis? 1 more pi over 3 is left. So our theta prime, our reference angle, is pi over 3. It's positive. It's between 0 and pi over 2. It connects to the x-axis, pi over 3. Okay? Do another one. Oops. Or 4 more. I'll stop talking for a moment. You start doing these, and then I'll catch up and we'll do them together. Pi over 3.
So all in that will be next step.
No, this is 5. This is 5 pi over 3.
Yeah.
So reference angle is how far you go to get back to the x-axis. Which is 1 more pi over 3. You want to draw your pictures and then figure out your reference angles. I'll jump in and go over them. So let's see what you guys can try on your own first. Let me go over that part. So we've got 210 degrees. We're going to go around 180, and then we're going to go how much further?
30 degrees.
30 degrees further. So our reference angle is the acute angle that connects to the x-axis. You don't want to go the other way, because that's going to be more than 90 degrees. You want to go the shortest way to the x-axis, the shortest way. So that's going to be a 30-degree angle. Question? it's okay that it kind of drew over the original angle. That's okay. Because you went to the wrong axis. Yeah, you always go to the x-axis. Always go to the x-axis. Okay, so how about the next one? We've got negative 260 degrees. So we're going to go negative 90, negative 180, negative, almost there, negative 260 degrees. We're going to draw our angle that goes to the x-axis, the shortest way possible to the x-axis. How much is that? From 180 to 260, 80 degrees. So we're drawing the shortest distance to the x-axis. So make sure we go to the correct axis. All right, next one is in radians. So we want to think about pi divided by 9 first. And this one's going negative, so I'm going to look at the bottom half. So we're going negative. How many spots should I have on the bottom? 9 of them. But how many am I actually doing? 7. So how many places are going to be left? 2 pi over 9 to make the full pi. So there's 7, 1, 2, 3, 1, 2, 3, 4, 5, nope, 7. And then I have 2 left to make that full pi. Again, we're going the shortest distance to the x-axis. The last one is 15 pi over 4. So how many divisions are going to be on top here? 4 of them. But I'm doing 15 of them. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 14 and then 15 is here. Maybe a better way of thinking, maybe not a better way of thinking about it. 2 pi is the same thing as 8 pi over 4. Those are equivalent. 2 pi is 8 pi over 4. So I have 8 pi over 4 is all the way around. And how many pi over 4s do I have left? I would have 7 pi over 4 left to make that complete 15. Oh, that's not my answer, though. Yeah, that's not my answer. My answer now is what is the reference angle, what's left to get us straight up to that x-axis? So pi over 4 left. Pi over 4 left. I think if it's over 4, it might always be a pi over 4 left. Maybe. No, maybe not. Okay.
Yeah,
Well, if there's a reference angle, if it ends here, that would be one of those quadrantal angles. Ooh, do you remember the term quadrantal? Probably not. Do you remember the term quadrantal? I'll say it again. Don't worry. Okay. The next section talks about something that we've already kind of talked about today when we filled out our unit circle. It talks about the negatives and positives in what quadrant. I'm not going to use this chart. I'm going to use the fact that I know that x's and y's are positive in this quadrant. That in this quadrant, x's are negative, y's are positive. You guys know this already, right? In this quadrant, both. I'm using this. I'm not using each individual ratio. And then this one, what's positive or negative? X is positive, y is negative. They have tangent and cotangent here. We haven't talked about tangent, cotangent yet. But how do you find tangent? It's y over x. So when we look here and we see both are positive, we know tangent's going to be positive. We look here and one of them's negative, we know tangent's going to be negative because one of them's negative. Here, they're both negative. So if I do both negatives, tangent's positive. And here, one of them's negative, so tangent's negative. Okay, these are the steps of what we're going to do. I'm not going to keep reading this, but this is the steps I'm going to do every single time. We're going to first find a reference angle. We're then going to find the trigonometric function for that reference angle. Then we're going to determine the sign for the actual answer. We're going to do 3 steps. What we're trying to do is do something like find the tangent of negative 240 degrees without a calculator. So the first thing that you're going to do is you're going to draw and figure out your reference angle. So negative 240 degrees. Draw and figure out a reference angle. So here's negative 90 degrees. Here's negative 180 degrees. Negative 270 degrees. So negative 240 is about here. What is our reference angle? What is it? From 180 to 240? 60. Positive 60, because reference angles are always positive. So that's step 1, find the reference angle. We're going to put a little step 1 in there. Step 2, what we're going to do is we're going to find the tangent of the reference angle. So we're going to do the tangent at 60 degrees. And that, my dears, is in that chart. What's the tangent of 60? Just radical 3. Just radical 3. So that's why we have to memorize that chart. Because you got to be able to tell me what the tangent of 60. Radical 3. Okay? The last step is we are now going to do the tangent at negative 240 degrees by finding the correct sign for this quadrant. So we were just talking about tangent. Tangent is y over x. Tangent is y over x. And if we're in the second quadrant, the x is negative, the y is positive. So this is going to be a negative answer. And then it's just the exact same answer that the reference angle gave us. It's just negative square root of 3. So that last step is just finding the correct sign. Step 2, you're finding the number, and then you put them together. Okay? Nope.
Sure.
We need practice with this. We definitely need practice. It's not going to come like all of a sudden you're going to be like, oh yeah, I totally know what to do after one example. So the first thing we're going to do is find our reference angle. Okay. 17 pi over 6. What's 2 pi when it's like over 6? What's 2 pi? No, I mean something over 6 is equal to 2 pi. 12 pi over 6. So this 17 pi over 6 we know goes all the way around 1. And then from there, how much more does it go? It goes 5 more pi over 6. So do we make it all the way to pi? No, we go about here. So we take the shortest distance to the x-axis, that's our reference angle. What is our reference angle? Step 2. We need to figure out the cosecant at pi over 6. Now, I'll tell you how I do this. I know what pi over 6 is as degrees. What's pi over 6 as degrees?
Where did you get the 5 pi 6?
So all the way around once is 2 pi, right?
Right.
Which is 12 pi over 6.
Okay.
So I subtracted that from 17.
Okay.
And then I have 5 left over to keep going. So anytime we have pi over 6's, that's always my 30. It's either going to be 30, 45, 60, or it's going to be one of those quadrantals, or you can't do it by hand, by like memory. Okay, so pi over 6 is 30, so now the next thing I'm thinking is what's the cosecant of 30 degrees? That's what I'm thinking. I might not write it, but that's what I'm thinking. What's the cosecant of 30 degrees? And you might not have your cosecants memorized, but I know my sine of 30 degrees. So the next thing I might be thinking is what's the sine of 30 degrees? And you tell me 1/2. Oops. So then I flip it. What's the cosecant of 30 degrees? 2. Okay, this is like how I think through it. You might just have memorized the cosecant of 30 degrees is 2. You might memorize that and then know it, but I don't memorize it. I go off of sine. Okay, so we know the cosecant is 2. Then we have to figure out the correct sine. So step 3, we have to look which quadrant it's in. This is in the second quadrant.
So it's absolutely not have to worry about it.
And cosecant is sine, which is y. It's actually 1 over y. But when we're talking about the y value in the second quadrant, is y positive or negative in the second quadrant? Positive. So my answer is positive 2. So my last step is just determining positive or negative. That's my last step. Let me confuse stuff. Nothing yet? Okay, let's do another one. 4. Plenty of time. Okay, evaluate cotangent negative 210 degrees. So we're going to first draw our reference angle. Draw our reference angle, negative 210. We're going to go negative 90 degrees, negative 180 degrees, negative 210 degrees. What is the reference angle? 30. So that's step 1. Step 2, we need to do cotangent of 30 degrees, the reference angle. So if you don't have that one memorized, you might think, what's the tangent of 30 degrees? And if you don't have that one memorized yet, then you're going to have to look it up. I know the tangent of 30 degrees is radical 3 over 3. So the cotangent of 30 degrees is just radical 3. Ooh. So my final step is determine what sine cotangent is in this quadrant. So cotangent is x and y. One of them is negative. So the cotangent of negative 210 degrees is negative radical 3. Yeah, and I'll teach you a trick of how to remember it next time, but right now we're just figuring it out by knowing what's x and what's y. And then I'll teach you a trick next time. All right, next one. Cosine 10 pi over 4. So we're thinking pi over 4. Those are the 45. So we've got pi over 4. We've got 1 pi over 4, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this one does not end up in outside the quadrant. This one is what kind of angle? I already said it. Quadrantal. So this one is what you did last night for homework. What ordered pair is that? So this says, what's the cosine there? No. Cosine is x. Cosine is x. We do not have to worry about sines for that one because it's 0. All right, so there's 2 you try. You try. So you have an idea of what you don't understand by you try.
Most of everything.
Go through the steps. What's the first thing we have to do? Are you confused about finding the referencing?
No.
Okay, then do that first. You have to take it step by step. Right. Yeah, I just possible.
It should be negative because it's in the second quadrant. It's Jimmy Clark's quadrant.
We did it. We'll be up on the board in a moment. So we're counting by times, right? Just like that. That's, you're counting by times. It comes from practice.
Go.
So cosine to x power
Okay.
I can do it with the degrees. I understand that.
I know. Okay, I'm gonna go through these. Can't remember, did I pause it? I don't think I did. Nope. So cosine negative 210 degrees, we're gonna go negative 90 degrees, we're gonna go negative 180 degrees, and end up at negative 210 degrees. And that gives me a reference angle of 30 degrees. So then we do cosine of 30 degrees. And you have that memorized? Square root of 3 over 2. And then we think about the sine. And cosine is always x. Cosine is always x. So in this quadrant, is x positive or negative? Negative. So negative square root of 3 over 2. And then we've got secant of 11 pi over 4. So I'm going to think pi over 4. So I'm going to think about dividing the top half into 4 equal places. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, but I need 11. I'm going to keep going. So this all the way around is how many pi over 4s?
8.
8. So I have how many more?
3.
3 of them.
Trace.
So we go to 11 pi over 4, and we have a reference angle of how much is left to get back. 45 degrees, but I'm going to write it in radians. Pi over 4.
Oh, okay. This is starting to make a whole lot more sense.
It comes from practice. My reference angle is pi over 4, which we know is 45 degrees, and believe me, I always think about it being 45 degrees. So I need to know what the secant at pi over 4 is. That's the same as the secant at 45 degrees. That's the reciprocal of the cosine. At 45 degrees, which is square root of 2 over 2. What is the secant at pi over 4? Just square root 2. And then we think about sine. This one, for some reason, every example I gave you is always in the second quadrant. I don't know why. This one is also in the second quadrant, so negative for cosine. So our answer, secant at 11 pi over 4 is negative radical 2. Okay, I'm going to put the assignment up on the board. It is in the book. It's on the exact same page that your assignment last time was on. So if you took a picture of it already, then you don't need to retake a new picture. You already have it. I don't have the laptops because of the testing, but I do have 4 more books over there, so we're really going to have to share, unless you brought your own book.